Afternoon, guys. Here with an explanation of session 4, which is ionic bonds. When we have an ionic bond, it is very, very important to remember that this will only be between a metal and a non-metal. These are the only two groups on the periodic table that, or larger groups on the periodic table that can form an ionic bond. What happens during an ionic bond is there is an electron transfer taking place, all right? So, which means that previously we spoke about covalent bonds, where the electrons were shared between the two atoms, but now transferring takes place, which means that one specific element gives away one of its electrons to the other element to make the other element a noble gas or noble gas structure, so that the final orbital will be filled with 8 electrons. This is just a way that I remember the difference between covalent and ionic bonds. If you look at covalent, cooperation, so if you're working in a group, you can say co, so you're sharing. When we look at the word ionic, this IO is sort of the beginning of IOU, if we have an IOU, which means that someone is going to give something to someone else. Okay, that's just my way of remembering it. Hopefully that will also help you guys to remember. Once again, I set out a set of rules for you guys to use when you are working out your ionic structure or your ionic bonds. I'm going to use the larger format. Right. So just as with the covalent bond, number 1 and 2 is the same. You go and determine your valence electrons and you draw the Lewis dot diagram for each of the atoms. All right. The only difference here is you are going to use an arrow to show where the specific electron will go to, and your final drawing will have to be with charges as well. All right. Let's go and look at an example. Let's say, for example, I ask you to go and draw the reaction or the ionic reaction that takes place between sodium and chlorine. So let's just say I give you sodium chloride. And I say, go and draw the specific electron transfer that takes place using Lewis diagrams. All right, let's get our rules in front of us. First rule, we're going to determine our valence electrons. How do we do this? We use our periodic table and the numbers at the top that we've numbered previously. All right, so let's go and look at sodium. Sodium, there we go, has 1 valence electron, and chlorine has 7. So you can already see chlorine is much closer to having 8 electrons in the final orbital than sodium. So your sodium is going to give an electron to chlorine, so that chlorine has 8 electrons in order to make it and give it a noble gas structure. All right, so we go and draw our Lewis diagrams. We have sodium with 1 electron, and then we have chlorine with 7. 1, 2, 3, 4, 5, 6, 7. All right. Then you go and draw an arrow. You physically draw the arrow to show me. There's a spot for it. You don't have to draw the X. I'm just showing you guys. There is the spot. So then this chlorine atom will have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Okay. But what do we know when atoms give away electrons or gain electrons? They gain a charge. So in your final answer, you will have to indicate your charge. So my next arrow, I'm going to say, okay, my sodium lost an electron. So it has 1 less electron, so it is 1 positive. And my chlorine gained an electron, so it has 1 extra negative. And then make sure you draw your 8 electrons around chlorine, and then you just write your final answer, sodium chloride. So you will see here we have a positive and a negative. Let's do one more example. Let's do calcium chloride. Let's say we have calcium chloride. Okay, so now we go and write calcium. Go to your periodic table to look at the valence electrons. There's calcium. Calcium has 2 valence electrons. Sorry, my cat. So we are going to draw 2 little dots. And then chlorine, as we saw in the previous example, has 7. 1, 2, 3, 4, 5, 6, 7. So you can see there's a spot there. So one of them can go there already. So we're going to need another chlorine. 1, 2, 3, 4, 5, 6, 7. So there's a spot open there, and that one will go there. All right. Now we have it lost 2 electrons. So it's got 2 extra protons. And here we have 2 chlorines. Both of them gained an electron, a negative charge. So they have 8 electrons around them now. And then my final answer is 1 calcium, 2 chlorines. If you go and check on the periodic table, you can double check yourself. Calcium chloride, remember when we used valencies to go and determine what the formula will look like. Remember, calcium has 2, chlorine has 1, and when they are different, you simply swap them around. So calcium chloride will look like this, and the reason for that is calcium had 2 electrons to give away to chlorine, but in order to do that, it had to have 2 chlorines. So then you have your 2 chlorines, both with a negative charge each with 8 electrons, and your calcium lost 2 electrons, so it now has a positive 2 charge. And those are your ionic bonds.